In this lecture, we will discuss about a device known as an alternating current generator or AC generator. Dear student, generator, there are two types of devices. First type of device is known as generator, whereas second type of device is known as motor. Generator is derived from word generate, which means that generator is a device which generates. In a simple word, if I define a generator, generator is a device which convert a mechanical energy into electrical energy. Mechanical energy into electrical energy. Now, dear student, please keep in mind generator can only convert a mechanical energy into electrical energy, but it is not interconvertible in a generator to convert an electrical energy into mechanical energy. This is basically a unidirectional device which basically only convert an electrical energy, a mechanical energy into an electrical energy. So now, according to the law of conservation of energy, total amount of energy remain conserved. So the amount of energy, net amount of energy, when there will be a mechanical energy in a generator, that will be basically converted mostly into an electrical energy, but the amount of the energy will remain conserved. Now, interesting point to notice here is that there is another type of device which is known as motor, and the motor basically convert electrical energy into a mechanical energy. So we can define a motor that motor is a device which basically converts electrical energy electrical energy electrical energy into mechanical energy Common example of motor which are used in daily life is just a fan. You can check that in a fan we basically just used an electricity or a potential, and it's just taught the mechanical movement. So the fan basically is based on the principle of an electric motor. The fan act as an electric motor, whereas in case of generator basically convert a mechanical energy into an electrical energy. Student, please note that there are two types of electrical energy. They are based on two types of current. One type of current is known as direct current, and second type of current is known as an alternating current. So direct current is a current which flow in one direction. It is a unidirection current, which flow in one direction, and basically the current in a direct current basically flow from a positive terminal of the battery toward the negative terminal of the battery, whereas electron in direct current batteries flows from negative terminal of the battery toward the positive terminal of the battery. So the generator which are based on direct current, such type of generators are known as DC generators. Now, second type of current is known as an alternating current, a current whose polarity changes with time. Though the current will flow from positive terminal, positive terminal to the negative terminal of the source, but in AC current, in AC current generation source, the positive terminal sometimes change into negative terminal, and in some instant of time again the negative terminal changes into a positive terminal. So in this way, polarity of an alternating current changes. So this means that a generator which is based on alternate current is known as AC generator. And in AC generator, they basically produce mechanical because an AC generator mechanical energy is converted into an alternating current, or it is converted into alternating current electrical energy. So whenever an electricity is gained by in an alternating current generator, then the electricity achieved or received by the alternating current generator will be alternate current based electricity. So now this will let us conclude the alternating current generator. Alternating current generator is a generator which convert a mechanical energy into alternating current electricity, or into AC based electricity. Now let us discuss about the construction of alternating current generator. What are the essential component of alternating current generator, and how we can generate an alternating current from alternating current generator. This AC current generator consists of four basic components. First component of AC current generator is known as permanent magnet. Permanent magnet. Permanent magnet is a magnet which basically provide uniform magnetic field. Since you know that every magnet has a magnetic field associated with it, and number of magnetic field passing through a unit area or passing through an area is known as magnetic flux. Whenever, according to Faraday law, whenever there is a change in a magnetic flux, then there will be a generation of electromotive force. So now in AC current generator, permanent magnet is used, which means that magnetic field of line B are constant, and this means that magnetic flux is constant, and when magnetic flux is constant, then induced EMF will not be produced just because of the permanent magnet. So this means that a static magnetic permanent magnet used in AC current generator is just to provide a magnetic field inside the alternating current generator. Second important part of the alternating current generator is known as armature. Armature is a very simple part of alternate current generator. It is just an soft iron cylinder, soft iron cylinder, which is winded by insulation of copper wires or coils. Okay, so armature is basically it is just a simple iron. It is just a simple soft iron cylinder which is basically covered or which is winded by copper, insulated copper wires. So the role of armature in alternating current generator is very important, since you know that armatures is basically consist of a wire, copper wires, and so whenever if this armature is basically in AC current generator, the armature rotates along its own axis. So you know that there are an armature is placed between the permanent magnetic poles. So whenever this armature rotates in a permanent magnetic poles, there will be a change in a magnetic flux. And the change in a magnetic flux will basically result into an induced EMF in armature. And hence a current will be generated in armature wires. So now, whenever this current is generated in armature wire in AC current, there is another part which basically connect the end of the wires of armature. The third part of alternating current generator is known as slip rings. Slip rings are made up of copper. These are copper rings. Now, students, please keep in mind the role of slip ring is very important. Slip ring basically weld. They basically bound or weld ends of copper coil. Since you know that copper has coils are basically they are in a form of a wire. So the wire of copper have two ends. So the two ends of copper wires are basically welded with two slip rings. So this means that the copper wire are fixed in a slip rings. They will not change in their position according to the slip rings. They are fixed in a copper slip rings. So now the current from alternate current generator are basically inside the are generated. They basically it's reach into a slip rings, and these slip rings are connected with another part which is basically known as carbon brushes. Carbon brushes. So the carbon brushes in alternate current generator act as terminal terminal terminals. They basically provide they basically transfer internal current internal current internal current into an external circuitry. So basically the carbon brush act as a terminal, and it provides a current from which is gained from the inside of the AC generator to the external environment. So now these are the four basic components which are present inside the alternating current generator. The first important component of alternating current generator is a permanent magnet which provides uniform magnetic field. Second part of the alternating current generator is armature, which basically move along its own axis, which rotate along its own axis, and due to rotation of armature along its own axis, there will be a generation of a magnetic flux. And whenever there is generation of magnetic flux, there will be production of induced EMF. This induced EMF is transferred through a wire of copper into a slip rings, and the wire of coppers are basically fixed with the slip rings. So from the slip rings they are transferred into slip rings. There is a connection of carbon brushes, and the carbon brushes basically will transfer the current which is gained from the slip ring into the external environment or into the external circuitry. So in this way alternating current generator works. Now let us explain alternating current generator or AC generator with a schematic diagram. We will also explain that how current flows in produced and flows in an alternating current generator with this schematic diagram. So this is a block diagram for alternating current generator. If we can clearly see that an alternating current generator has a magnetic poles, and these magnetic poles are basically are from a permanent magnet. There is a north and south pole of the permanent magnet. Since you know that permanent magnet have uniform magnetic field of lines, and these magnetic field of line basically move or travel from north pole toward the south. So this is basically a direction of magnetic field of lines. They travel from north pole to a south pole. Now, please keep in mind that the magnet is permanent, so which means that a magnetic field of lines have a permanent or uniform magnetism. So the magnetic field of line will have equal strength, and the magnetic field B is basically it will be uniform. So the magnetic flux, which is basically represent a flow of magnetic field of lines passing through an area. So the magnetic flux is uniform, which means that whenever there is no change in the magnetic flux, in such cases induced EMF will be zero. So in alternating current generator, the magnet which is used have a uniform magnetic strength, and the magnetic field strength or magnetic flux of this magnet on its own is not changing. So it just produced a magnetism or magnetic field of lines inside the AC current generator. So there is another important component of AC current generator, which is known as armature. This is rectangular shape is a representation of an armature. Armature is consist of a soft iron core, which is an iron cylinder, and it is wrapped or winded by copper wire. So this is basically this line is basically a representation of an armature coil, which is basically a copper insulated copper coil. So the role of this armature is very important in alternating current generator. If the armature is static, it is not moving, and the magnetic flux is also uniform, magnetic field of lines are also uniform, then there will be no generation of an electric current and induced EMF. So whenever this armature rotates in this permanent magnet, the rotation of armature will cause a change in strength of a magnetic field, or it will cause a change in a flux. And whenever there is a change in flux, there will be a generation of electromotive force, and there will be a generation of electric current in a wire of armature coil. So armature basically produced electric induced electric current inside the alternating current generator by its rotation. So in AC generator, armature rotates along its own axis. So whenever the current is produced inside the wires of armature, the wires are connected with two rings. These are two, the blackish one represent two rings. These are called slip rings. They are made up of copper. These slip rings have very important role, since the armature is based on copper coils, and these copper coils are consist of, they have two corners. One corner of copper coil is welded with one of the copper slip ring, and similarly another coil of copper is welded with next one slip ring. So both are welded. These copper are coil of armature, they are welded, they are fixed, so they will not move. Okay, they are welded with these with the rings. So now the current from the armature is transferred into a ring. Now there is another part in the AC current generator which is known as brushes. These are carbon brushes which are connected with the rings. So the slip rings are connected with carbon brushes, and carbon brushes act as a terminal for the AC current generator. So basically, they either take off the current from the AC current generator, or they either take in the current into the AC current generator after the completion of external electric circuit. So now let us discuss how an alternating current is produced in this AC current generator. This current initially uh, an armature coil or an armature is rotated either clockwise or anti-clockwise. Suppose that the armature is rotated along the anti-clockwise direction, along the direction. So whenever this armature is rotated, then there is a change in a flux. There will be a change in a flux. And according to Faraday's law of electromagnetic induction, the rate of change of flux result into an induced EMF. So basically the AC current generator, alternating current generator, work on the Faraday law of electromagnetic induction. Whenever there is a rotation of rotation of armature inside the permanent magnet, there will be a generation of electromotive force due to change in flux. So now the armature is rotating anti-clockwise. Please keep in mind that the magnetic field of lines are from north pole to south pole like this. So according to the right hand rule, the current generated will be along the downward direction. So in this way, an induced current, sorry, let me clean it and write it very clearly. So in this way, the induced electric current, whenever the electric field, the coil is rotating anti-clockwise, so the half of the rotation will generate an electric current, and that electric current will be along the downward direction. Electric current is induced current. And in this way, in the downward direction, this electric current will move and it will reach to the slip ring. And whenever it's reached to a slip ring, it will then go to an external circuit through the brushes of the carbon. And in this way, after the completion of this current passing through an external circuit, it will again go toward the AC current, and in this way, through a carbon brush, the current will again reach to the alternate current generation of current generator after the completion of. So in this way, a continuous induced electric current is generated into AC current generator. Please keep in mind, for current it is important to have a closed circuit, or a current require a path to move through it. So the initially current will be produced and it will go out into an external circuit, and the path will be completed by current just complete after going through alert. It's again reached to the AC current generator. So now there are some points you need to know. The magnitude of alternating current will depend on the strength of the magnet, or strength of the permanent magnet. It will depend on the diameter of armature. It will depend on the speed of rotation of armature inside the permanent magnet. And second most important point to notice is that one side will always, all like this side will always have a direction of current directed downward, whereas the other side will always have a direction of current pointed upward. Please note that the direction of current is determined by right hand rule or left hand rule, and it may be also determined by Allen's law. So every source which is basically responsible for the generation of induced EMF, it's basically its direction will oppose the source which is causing the generation of induced. So in this way, basically an alternating current generator works. Important question to notice is that how we can say that a current produced by this generator is an alternate current. The answer is quite simple. Dear student, since you know that the magnet is permanent magnet have a magnetic field of line which are directed from north pole toward the south pole in AC current generator. Okay, they are like this. So now the current if the armature of alternating current generator is basically rotating in anti-clockwise, then the direction of the current on this right side will be toward the downward. So this will be a direction of the flow of the current, and whereas on the opposite side the direction of flow of current will be upward. Induced current is upward. So now, since you know that positive terminal, the current flows from positive terminal toward the negative terminal of the source or of the battery. So now the current is flowing in this direction toward the downward direction. So then this ring will and the bush with attached with this ring will act as a positive terminal because current is flowing through the positive terminal, whereas the current uh, is basically from positive terminal, it goes toward the negative terminal. So this side of the ring will act as a negative terminal. So now, since you know that the the armature basically rotates, it's rotate either anti-clockwise or clockwise in the between the permanent magnet, we consider that it is rotating anti-clockwise. So initially, if it is at position C, if armature rotate anti-clockwise, then the position C will come here, and whereas the position B due to rotation will come here. So this means that the position B will change into a positive terminal, whereas the position C here will be converted into a negative terminal. So in this way, a positive terminal, there will be a switching between a positive terminal and negative terminal, which means that there will be a switching of positive and negative terminal. Basically is called a switching of current, which means that or switching of a polarity. And this switching of polarity continuously switch on with respect to the rotation of the armature inside the permanent magnet. So the keep in mind that the wire of copper are connected or fixed with the slip rings, and these are welded, so they will be fixed. Just their position with a rotation will with anti-clockwise rotation or with clockwise rotation, their position with respect to the magnetic field, that will change, and in due to the change in a position, there will be fluctuation of the flow of current. There will be fluctuation of positive and negative terminals, and due to fluctuation of positive and negative terminals, there will be a change in a polarity, and the change in a polarity with respect to time is basically a current whose polarity changes with respect to time is basically known as an alternating current. So in this way, an alternating current in an external source or will be in an external circuit is received by an alternating current generator. So now dear student, let us calculate the magnitude of induced EMF. What is total amount of induced EMF in an AC generator? Suppose that the coil of the AC generator or the armature of AC generator is rotating anti-clockwise. So whenever it is moving anti-clockwise, this means that the magnetic field of line, since you know that they are moving along this direction from north pole toward the south pole. So now the coil is moving anti-clockwise, which means that there will be electrons in a coil, and these electrons in a coil will move inward. They will move inward with a rotation. Okay, so when they are moving inward and the magnetic field of line which are along this direction, so this means that the magnetic field of line will push the electrons. Electrons are moving inward, they are moving inward, whereas magnetic field of line B is basically it is along this direction. So they will basically, magnetic field of line will interact with electrons. So the electrons are basically, they, due to the push, the electron will start to flow in this direction. And since you know that the flow of electron, basically flow of electron tell us about the electric current. But however, in a normal electronic circuit, the flow of the current is determined in a conventional way, and it is from opposite to the flow of the electron. So the flow of the current will be along this direction. Similarly, the direction of electron changes and on this side, and the flow of electron will be along this directions. However, so this means that induced EMF will be produced on this side and as well as on this side of the armature. Now keep in mind that whenever the conductor is moving in a uniform magnetic field, there is a generation of electromotive forces at the edges of the conductor, or at the end or at the corner of the conductor. So induced EMF on this side and this side are generated. However, induced EMF on this side will be zero, and similarly induced EMF on this side will also be zero. Why induced EMF on these both sides will be zero? The reason is quite simple, that magnetic field of lines are moving along this direction, okay, and whereas there are an electrons in a coil, but the electrons are basically, when they are moving either inward if the motion is clockwise, or they could be moved either inward and outward. So the magnetic field of line will interact with them, but there is no direction or path for electron to move in a coil. So due to this, the electron cannot, there is no path for them. Due to this, the net EMF will be zero, because there is no flow of current for them. So this means that only these two sides, the right side of the armature, and as well as the right side of the armature and the left side of the armature, these armature part of the armature will have induced EMF, whereas this side and this side, they have no path for electron to flow. The induced EMF will be ineffective, and the current in them will be zero. So this means that the total EMF EMF induced will be the EMF induced on side CD plus the induced EMF induced on the side BA. Okay, so now as you know that the motional EMF, the formula for motional EMF is VBL into sine of theta. So now in AC generator, two EMFs are effective. So the induced EMF in AC generator will be EMF will be VBL sine theta plus VBL sine of theta. So the net EMF will become, net induced EMF will be in alternating current generator will be 2VBL sine of theta. So dear student, please keep in mind that V represent a velocity of the armature, and B is a magnetic field and L is the length of the armature. Now keep in mind that armature in AC current generator rotate, and you know that for rotation we need the velocity. V is a linear velocity, and we need to convert this linear velocity into a rotational velocity. Since you know that linear velocity, relationship between linear velocity and rotational velocity is that V is equal to R into omega. R is the radius of armature. So this means that rotational velocity omega will be this means that we can incorporate the value of linear rotational velocity in, suppose this is equation 1. So we can incorporate the equation 2 value of linear velocity equation 2 into an equation 1. So we can basically get induced EMF in AC generator as 2R omega into BL sine of theta. Now, dear student, please keep in mind that radius is basically, it is represent a half of the cylinder, so a half of the armature. So the breadth of the cylinder is basically equal to 2 times radius of the cylinder. So we can basically and then the radius become b by 2, half of the breadth of the cylinder. So we can basically, suppose this is equation number 3 and this is equation number 4, we can incorporate equation 3, equation 4 in equation 3. So we can get induced EMF is equal to 2b by 2 omega BL sine of theta. So 2 will cancel with 2 and we can get basically B omega L sine of theta. And we forgot the B, we write B magnetic field here. So now the formula for induced EMF in AC generator become induced EMF become B omega L sine of theta. So now, since you know that, suppose let's say this is equation number 5. Since you know that breadth into length of coil is equal to the area of the coil or area of the armature. So we can write this formula as E is equal to induced EMF is equal to B, which is magnetic field, into the area of armature into omega sine of theta. So this is equation for induced EMF in alternating current generator or AC generator. So now we can basically switch this equation in different ways. As you know that theta, which is a angular displacement, this means since you know that the value of motional EMF is represented by equation that induced motional EMF is equal to V B L into sine of theta. Now, in case of AC generator, the two EMFs are from of the, at the edges are useful. So induced EMF in AC generator will be equal to VBL sine theta for one side or one edge of the generator plus of armature plus VBL sine of theta for second side of the armature or generator of second side of the coil of the armature. So net induced EMF for two sides will be equal to 2VBL sine of theta. So now, dear students, since you know that an AC current generator armature is basically rotating. So here in equation, the V is basically it is a velocity which is linear velocity. Okay, linear velocity. So we need to change this linear velocity into circular or angular velocity. So as you know that linear velocity V is equal to R into omega. So this is description for angular velocity. So suppose this is equation number 1, this is equation number 2. We will incorporate equation 2 in equation 1. So we get net induced EMF is equal to 2 R omega BL sine of theta. Keep in mind that R is a radius of a coil or armature, omega is an angular velocity, B is a magnetic field, and L is basically a length of a coil or length of a wire of an armature. So now, as we know that breadth of a coil is basically breadth of an armature is equal to 2 times radius. So then radius become b divided by 2. So now incorporate this 3. Suppose this is equation number 3 and this is equation number 4. So if we incorporate equation 3 and equation number 4, we get net induced EMF is equal to 2 breadth divided by 2 into omega BL sine of theta. So 2 will basically cancel 2 and we basically then the remaining equation will be net induced EMF is equal to 2 into breadth of the armature into omega into B L sine of theta. Suppose we say to this as equation number 5. So now, as we know that breadth into length is equal to area. So area of armature is basically it is equal to breadth into length. So we can write equation 5. We can incorporate equation 6 in equation number 5 and we can get net induced EMF in AC generator is equal to 2 into area of armature into omega into magnetic field into sine of theta. Okay, so this is the total EMF induced in alternate current generation. So this is the formula for the total EMF. We can basically just play with this formula since as you know that theta is equal to 2 pi f. Sorry, but just by mistake, we have added the two is basically it was cancelled. It was basically cancelled here. Okay, so the formula was basically net EMF is equal to B omega BL sine of theta. So now breadth into length is equal to area. So we can basically write length and breadth into area is equal to area. So induced EMF will be equal to B into area into omega uh, A into omega B into sine of theta. And now as you know that theta is equal to 2 pi f, so we can write this equation number 6 as induced EMF, net induced EMF is equal to area into omega into B total magnetic field into sine into 2 pi f. So now dear student, please keep in mind that there are number of turns uh, in a coil. Okay, so the number of turns are basically directly proportional to the induced EMF. So greater will be number of turns, greater will be the induced EMF. So we will incorporate number of turns in this equation. So we can get basically net induced EMF in AC generator as A into N is the number of turn into A into omega into B into sine of 2 pi f. This is called equation number 7. So now, the equation for AC generator as a whole, which is a general equation for AC and generator, will become E induced EMF is equal to A. It is E induced EMF is equal to area of the armature omega B, and it will depend on the number of turns. So we will write N here. So this will be basically a net induced EMF produced by alternating current generator. So now, dear student, please note that the role of theta is very important. On the basis of theta, basically, we can generate a wave diagram for AC current generator. So now let us generate a wave diagram for AC current generator.